Hello millennials and Gen Z. In this video, we are going to look single neuron code in PyTorch with the help of Google Colab. PyTorch is the machine learning framework in Python given by the Facebook, and Google Colab provides the code running environment by Google. Why we use Colab? Because when we write some mature machine learning code, then it will become big and needs a heavy GPU to run. To own that level of GPU, graphic processing unit, is expensive. So we just rent Google Colab and our work is done. You can think Colab as a machine in the cloud and you have the access to it. Okay, let's come to the code. In the code, there are four main sections. First section represents import the necessary library to create and test the model. Second section is defining the model. Third section to train the model. Fourth section to test the model. In first section, we import the necessary library from PyTorch like Torch itself, torch.nn which represents the neural network, torch.optim which represents the optimizer. In second section, we define the model class that must be derived from nn.module. In initialize section, we define the different layers, and in forward section, arrange the different layers. Whenever this model gets called with some value, implicitly it calls forward method, and forward then input passed through the different layers and return the output to the callee from the model. And here in initialize section we can see nn.linear, one input and one output. This is because we have just created a single neuron, so this is one input and one output, and this is arranged like this in forward. Third section is the most important one, as we instantiate the model class over here, single neuron model. This is this class, single neuron model. We instantiate here our model. Then we define a loss function. What loss function basically we use to calculate, loss function calculates the gradient, and this is the mean squared, simple mean squared error loss. So basically what we have seen is loss is y dash minus y. Here this squared error means it's y dash square minus y square. So this, with this loss function, it is going to calculate the gradient. Once the gradient calculated by the loss function, then comes into the picture optimizer. What optimizer did is, optimizer implements the optimizer changes the weights as per the calculated gradient. So gradient calculated by the loss function, optimizer implements the gradient and adjust the weight. Here in this optimizer, it follows systematic gradient descent with the learning rate 0.01. It is very less, but it's like that. This model dot parameters, in the parameter it asks for model dot parameters we provided over here. So this is our input x, and this is the output y, and this is torch.tensor. Why it is in tensor? It can be in simple output array. This is a simple array form, but when we write it like this, torch.tensor, we convert the array into tensor. It means it can also run into the GPU. If you do not use this torch.tensor and directly write the array, it will also work, but torch.tensor basically for the machine learning. Now this is helpful to run in the GPU as well. So it is good practice to follow. Like torch, we create the tensor over here, not the simple array only. So this is the output, and this is the input, and this is the output. 1 for 2, 2 for 4, 3 for 6. Now here the training goes for the for our model, like, yeah. So this is range 500, means it is going to repeat on the 500 times, means there is 500 epochs in this training. 500 epochs means it is going to train with this input and output 500 times. Optimizer dot zero grade, it empty the optimizer if there is any gradient accumulate over here. Then there is a forward pass, means we give the model the input x is not a single number, but it is a batch of input, like 1 2 3, like that. We give the input and we get the predicted value. Now this predicted value we are going to give to the loss function so that it can calculate the gradient. Yeah, so loss function, predicted value, actual output value, expected output value. So this gets, here we get the loss. Till here we didn't get the gradient. Now the backward pass, loss dot backward, when it goes backward it will calculate the gradient in this step, loss dot backward. Now optimizer, once the gradient gets calculated, optimizer comes into picture and is going to adjust the weight. So optimizer dot step actually adjusts the weight. That's our when the weight gets adjusted, that is the training, and it is going to print this what is the loss over there till now at every 100 repetition. As we run this loop 500 times, so every 100 repetition this message gets printed. Once the model gets trained, in a fourth section we are going to test our model. So we create our input data like this in tensor form, torch.tensor. Why tensor? Simple array will also work, but tensor will help the machine will help this machine learning to run in the GPU as well, graphic processing unit. Now we give the input to the model input test underscore x. We get the predicted value dot with the dot item predicted value. We hope the predicted value of 20 is 40. Let's see where what happens when we run this code. Running two section is simple, like first is simple import and second is defining the model. So let's run it. Yeah, they both run successfully in no time. Now the third portion is an important one. We put the print over here, like line number 15. We first print the initial weight. Definitely when model initiates, it will take some initial weight. Then this weight needs to be, then weight is going to be trained on this data, 1 to 2, 2 to 4, and 3 to 6. So that is some initial value. After that, as we know, the weight needs to be approaches to 2, because the appropriate weight for the single neuron should be is 2. So whatever be the random weight over here, after this training iteration, the weight approaches to 2. So here we, after every 100 iteration, after every 100 epoch, it is going to print the loss and the weight. So let's run it. Yeah, so it will quick one. So like initially the tensor value is 0.07. After 100 iteration, the weights get trained, and when the weight gets trained, its value is 1.7. After 200 iteration, this is 200 iteration, its value is 1.7. Basically, as a part of training, the weight approaches to the appropriate value, that is 2 in this case, but it will not approach to that value, it will approach to 1.8. Definitely this may happen. Like it is not always, because learning rate is very slow, so it approaches to the actual to the appropriate value slowly, and it goes in 500 iteration, 500 epochs, it reaches up to this only 1.8. When we test with this value, definitely we don't get the correct answer. Like for 20, for the input 20, we need to get the 40, but let's run it. What we get is 38.172 for 20, but what we require over here is 40. So let's do something, let's change something and run this code again. Either this 500 time to, where is the 500? Yeah, this is the 500. 500 to make it 1000 iterations. Let's make it 1000 iteration. Then we can run this third section. Let's run it. Yeah, now we see initially it is, yeah, so as we see, initially it can take any random value, then training happens, then training goes on, and after the training it approaches to its appropriate value. In this case 2, as we know, because there is single neuron, but it's billion of neuron, then it is hard to predict manually. Then definitely this program comes into picture. We need to understand this is going to be the basic, and with this help we can generalize the model with millions and billions of weights. Yeah, so here we see tensor is approaching initially it's 1.16, after 100 iteration it's 1.9. Means in the first 100 iterations it optimizes maximum, then after that definitely gradient is less, so it will improve slowly, definitely, but we can see it's improving, right? 95, 96, 97, 979, here 974, here 979, like that. And now it is going to give correct value, I suppose, near to the correct value. It's now it should be 40, but let's run it. Oh, 39.9 max correct value. I want it to be perfect, like 2. So what can we do? We can increase the learning rate over here. Let's the learning rate 2.1, but I think it is going to be very big, so let's reduce this to 500 only, and we run. Let's see what happens. Okay, we get the perfect 2 over here approaches with increasing the learning rate, because it is going to learn fast. And in 500 iteration, let's see, okay, in 400 iterations it learned, 500 iterations no change. Yeah, so now it's perfect. If we run it, oh, for 20 it's give 40. That's the example with single neuron, and this is the code. I will also going to attach this code in some attachment over there in the video, so you can find it over there as well. Thank you very much. Have a good day.